right, determine if the sequence is geometric. So there better be a consistent, constant number that's being multiplied from term to term. Okay, so how do you find it? Like dilation last year in im2, how do you find a scale factor, image over pre-image? It's, hold on, let me get over here. So what is 6 divided by -1? What is -36 divided by 6? What is 216 divided by -36? You are going to build a ratio. It's a geometric sequence. No adding or subtracting. You have to find out whether there is a ratio that's consistently being multiplied from term to term as you progress.
And if it's not geometric?
Right, if one of them's different, it's a fail. Okay, so you're going to have to, obviously, I'll reduce, but it's always the later one is the numerator, the earlier one is the denominator. Okay, so 6 divided by -1 is -6. -36 divided by 6, -6. 216. And there's my -6. And so what's your common ratio? We're going to call it R, you guys. It's -6. If only one of them is different, it's a no.
It's not geometric.
It's just a fail. It's not geometric. Skip it. There's nothing else for you to write. So here, you just write. It's okay. Can you bring me one? Yeah. This is weird. So if there is not a constant value that's being multiplied from term to term, then there is no common ratio. It's not geometric. It's not even arithmetic. It's not even that. Keep going. Okay, so you guys will do 3, 4, 5, 6. I'm going to jump to 7, 8, 9, 10 just so I can stop the video, so I can make one video of just those 2 sections. Okay, so then the next one, it says, given the explicit form for a geometric sequence, find the first 5 terms and then the 8th term. So make sure you find a to the 8th here, okay? Okay,
6.
I'm going to move this over. Okay, explicit formula. Okay, explicit formula for geometric sequences. So just like you had one for arithmetic, remember it was A1 plus and then parentheses n minus 1 times d. Because you're doing geometric, meaning you're multiplying from term to term, we're now dealing with exponents. So your n minus 1 is an exponent to that common ratio. It's not a multiplication like arithmetic. Okay? So if, and you're going to see it days and days, right? I repeat it. Okay, So let me copy 7 here. Okay, so from the sheet 7. Okay, for those of you that are like, wait, where's my A1? It's not even here. It actually is. This is the same thing as, it's equivalent to the initial term is actually 1, 3, n minus 1. So if you're okay seeing that, remember it's cleaned up. Remember like the quiz on Friday, I said, hey, extra credit if you guys want to simplify it down. You should know how to clean things up, combine like terms. Okay? Okay. This is not necessary, but if it makes you feel better that the initial term is 1, my common ratio is 3, right? So I'm multiplying by 3 from term to term. That's what this means. Okay, so if it wants me to find the first 5 terms, it says, given the explicit formula for a geometric series, find the first 5 terms and then find the 8th term. All right, so if I find the first term, I want n to be 1, right? Because that's the first term. Okay, so what's the value? A1 is equal to 3, 1 minus 1, and what is anything to the 0? Right? And that's why it was 1 there, right? So that supports it. So technically you're already given your first term. So A1 is 1. All right, what's my second term? What's 2 minus, wow, that was too close, too close. What's 2 minus 1? 3 to the 1, 3. Right? But if you understand common ratio, what am I doing from term to term? Right, so times 3. So what's my next term going to be? 9. The next one's going to be? Right, so I'm still going to do the substitution, you guys. Substitution. So what's 27 times 3? Me neither. 81? All right, so once you get your first term, you can find your first 5 terms, but let's keep substituting. So if n is 3, I want the third term. What's 3 minus 1? What's 3 squared? 9, right? So there's my 9. Put in the fourth term. What's 4 minus 1? And so what's 3 cubed? That's the same thing as 3 times 3 times 3, right? So you can go to your calculator, or just got to know those rules of exponents. Are you guys okay? Yeah, and then let me just write the 5th one, and then I'll we'll find the 8th term, and then I'll stop the video. So what's 3 to the 4th? Well, you know 3 squared is 9, so it's 9 times 9?
81.
81. But if you're using the calculator, right, 3, and then you can hit that little, where it has a little colored in square. You click that, it tells you to type what you want, and I want the 4th, right? I want the superscript or the exponent to be 4. So then equal, and there's my 81. Okay, they want us to go to the 8th term as well. You're welcome. 8 minus 1, so 3 to the 7th. What's 3 to the 7th? What is it?
I got 2,187.
Yep. Right? Or you could have just gone a to the 6, a to the 7, a to the 8. I mean, once you understand the efficiency of it, you're just going times 3, right? That's what common ratio means, right? Okay, I'll leave it here. I'll stop the video. get to the end, we'll tell you what it is. Oh, here, you know what? Let me find, I don't have the key.
Oh.
Let me find it and I'll look for it. Because I don't think I have, well, you know what? It was before the review. Hold on, I might be wrong. Oh, never mind. I was wrong, there you go.
Thank you.
Can I stop it? Yeah, okay, remember, it'll come back up. It just